To graph this equation, the first thing I notice is that it's a rational equation. So I'm going to look for vertical asymptotes. I know those happen at places where the denominator is 0. So set the denominator equal to 0. You get x equals 6. That's a vertical asymptote for this graph. Now I'm going to plot, or I'm going to figure out where some points happen to the left of that and to the right of that. If I plug in x equals 9, I get y equals 3 over 3. So I'm going to try to choose x values that give me nice y values if possible. And x equals 9 gives me a nice y value of 1. If I go to x equals 7, I don't get an integer. If I go to x equals 7, 3 over 7 minus 6 is 3 over 1. So I do get y equals an integer 3. That gives me 2 points to the right of the vertical asymptote. That's all I really need to complete the graph on that part. So now I'll go to the left of the asymptote. If x is 5, then y comes out to be negative 3. And if x is 3, y comes out to be negative 1. So I can plot this thing pretty quick. Notice I could have also graphed first y equals 1 over x, then shifted that to the right by 6, and then stretched that vertically by a factor of 3. That would give me the same graph. So you've got options for how to sketch this graph. Either way, not only will you get a vertical asymptote at x equals 6, you will get a horizontal asymptote at y equals 0. And it's usually a little challenging for college algebra students to see where the horizontal asymptotes happen. What you basically have to do is think about what happens to the y values when you plug in bigger and bigger x values, so you let that x value go out to the right towards infinity. For example, if I plug in x equals 100, I get y equals 3 over 94. 3 over 94 is a really small number. If I plugged in x equals 1 million, then y would be 3 over 1 million minus 6. That's a really tiny number. And as x gets bigger and bigger, y just continues to get smaller and smaller. But it will never hit 0 because the numerator is always 3. So that's why we're getting a horizontal asymptote at y equals 0.